All right. So let's take a look and let's actually write our equations up here at the top. So we will write our equation for V, all right, which is voltage, which equals our current times our resistance. Okay, so remember current is I, measured in amps, and then resistance, what's the unit for resistance? Ohms, okay? Voltage is volts. All right, so you got that equation. You have your equation for current, which would be voltage divided by resistance. And then we also could solve for the resistance if we needed to. So the resistance would be voltage divided by the current. Okay? All right, let's just take a look at the first one for now. It says an alarm clock draws 0.5 amps of current when connected to a 120 volt circuit. Calculate its resistance. So in this case, we're trying to figure out the resistance of this alarm clock. So we're going to use this equation right here. Resistance equals the voltage divided by the current. So we're trying to solve for R. Our voltage, it says, is 120 volts. And then our current in amps is going to be 0.5 amps. So 120 divided by 0.5, Skylar, what is that? 240. Okay. So it's 240. And then remember your symbol for resistance is ohms, which has the symbol omega. Okay. I would get used to putting the omega symbol because that's what you're generally going to see. Okay. I mean, I don't care if, I want you to know that it is ohms, but it's not a bad habit to get into the practice of putting the omega symbol because that's generally what you're going to see. So I want you to get used to seeing that. Sophia? What? Yeah, we're going to do at least one example of that. Let's actually take a look at the one on the bottom right. Okay. So this says what happens to the current in a circuit if a 10 ohm resistor is removed and replaced by a 20 ohm resistor. Okay. So we are concerned with the current in this case. All right. Look, this is what I would do. And this is what we're going to do right now. We are trying to figure out the current, which is I. So everything that we do down here is going to be I equals V over R. Current equals voltage divided by resistance, okay? Now, I would just make up values, okay, for your voltage to solve for your current, all right? Now, I'd pick something easy, all right, like 1. So if we're trying to solve for our current and our voltage, let's just assume is 1 volt. That's the easiest number that you can probably use. And the first one, we use a 10 ohm resistance. Okay? Well, in this case, your I is going to be equal to 1/10 or 0.1 amps. Okay? Now, you need to do this again. This time you're going to replace the 10 ohm resistance with a 20 ohm resistance. So I equals, now the voltage you want to keep the same. You want to make sure that's constant. So you put 20 ohms of resistance in there, and that's going to be 0.05 amps. Now, what happened to the charge, or the current, sorry? What happened to the current when you doubled the resistance? Look, it went from 0.1 to 0.05. What's the relationship between those two numbers? Anybody know? This is smaller, right? Okay. This is half of this. Toby?
Is it gonna double?
Well, you doubled the resistance, so that means it cuts the current in half. It's an inverse relationship. Basically, the opposite of doubling something is cutting it in half. So when you doubled the resistance, because it says what happens to the current if a 10 ohm resistor is removed and replaced by a 20 ohm resistor. So you double the resistance, it cuts the current in half. Okay? So that's an inverse relationship. Now, I will say the other one on the bottom is very similar. So this one's asking what happens to the current in a circuit if a 1.5 volt battery is removed and replaced by a 3 volt battery. So I would do that the same way. It's just you're solving for something, well, you're still solving for the current, but you are given the voltage rather than the resistance. So I would do the same thing and just see what happens to your current when you do that. All right. And the ones in here, they're pretty similar to the first one that we did. All right, go ahead and flip the page. Okay, now, I'm going to help you a little bit on this graph, but I'm going to let you do most of this on your own. So we are looking at a relationship between the voltage and the current right here. Okay, voltage and the current. Now, what do you think the slope of this line is going to be? Going to be resistance, because voltage and current, if you take the voltage and divide it by the current, that's going to give you the resistance. Okay, so your slope of this line should give you the resistance. So if you graph this, voltage is here on your y-axis, your current in amps is here on your x-axis. So like for the first point, we have 0.65 and then 0.12. So just do the best you can here. So that's going to fall somewhere about right there. The next point you have 1.41 will be right about here, and then 0.29, which should be somewhere around right there. The third point you got 2.55 and then 0.51, which should be right around there. Okay, so you can start to see the trend starting to take place. So I want you to go ahead and graph the last 3 points on there, and then think about the mathematical relationship that you see between voltage and current. Okay? Is it, and really, I'll give you two options here. Is the relationship a direct relationship? So as the voltage goes up, does the current go up? Or is it an inverse relationship where as the voltage goes up, the current goes down? Okay? So think about that and tell me, is it inverse or is it direct? And then, is the resistance constant? So is your line straight, okay, or is it curving? If it's straight, it's going to be constant. If it's curving, it's not. All right? And then down here at the bottom, I know these look intimidating, but they're really not. It really gives you all three variables except for one, okay? And so like right here, this gives you 12 volts and 10 ohms of resistance, and it's just asking what is the current, okay? So you have 2 out of the 3 variables, you're just solving for the third one in each one of these cases. Right here you have the current and the resistance, and you need to get the voltage, all right? So, you guys think you can do that? Okay. You have about 3 minutes. Okay. Tell you what. I'm gonna give you a little break today. I'm not gonna have you do this for homework, okay? But I will give you some time in class tomorrow to work on this. All right.